Okay, so we're now up to section 3 of the syllabus. The clarity of the signal transferred can affect interpretation of the intended visual communication. In order for a visual signal to be interpreted, it must reach the photoreceptor cells at the back of the eye in a clear and precise form. It is transferred in the form of reflected, transmitted, or generated light from the environment outside the eye through the transparent layers of the eye to the retina at the back of the eye, where a focused image falls on the rods and cones. To achieve this, the eye has transparent structures that must be maintained to perform their function of refracting light to the correct degree so that the image may ultimately reach the retina in clear and in focus. So the 2 dot points for today's video are: identify the conditions under which the refraction of light occurs, and identify that the cornea, aqueous humor, lens, and vitreous humor are refractive media. If you have ever tried to spear a fish in shallow water while standing on a beach or on a riverbank, you will know how difficult it is to pinpoint accurately the exact position of the fish. The fish that you see is actually an image, that is, reflected light that reaches your eye. In order to be seen, an object either reflects light, generates its own light, or transmits light to our eyes. The fish image that is seen is light that has been reflected through water, air, and then through your eyes. When light moves from one substance or medium such as water to another medium such as air, it is bent or refracted. This leads to a distortion of the image that you see, making it difficult to judge the exact location of the object at which you are looking. When light passes from one medium to another of a different density, the speed at which the light is traveling changes. As a result of the light speeding up or slowing down, the rays are bent or refracted. When you place a straw into a glass, it appears to bend. This distortion in the image is brought about by the manner in which the light reflects off the straw is being refracted. Light travels more slowly through the water at the bottom and quickly through the air at the top. Because movement of light in the denser medium is slower, it is refracted to a greater degree than the light traveling through the air. So this little video explains it a little bit nicer.
Light rays are bent or refracted when they pass from one semi-transparent medium to another. The refractive angle changes depending on the medium encountered. If a ray travels through air and enters a denser medium such as water, it is refracted towards the normal, a line perpendicular to the medium's surface. Rays entering a less dense medium will be bent away from the normal. If this occurs at a low enough angle, they are refracted 90 degrees from the normal. This is called the critical angle. If the ray's angle exceeds the critical angle, total reflection occurs. Light ray.
So, when light passes through a biconvex lens like this one here, the rays are refracted towards a central point known as the focal point, as we can see here. The rays then cross over and diverge or spread out from that point. If a screen is placed at a point in the pathway of the diverging rays, an image will land on the screen. The screen can be moved backwards and forwards until the image is clear and precise. The rays are said to then be in focus. If the image that falls on the screen appears blurred or is out of focus, this is because the focused image is falling either in front or behind the screen. It is interesting to note that the resulting image that forms once the rays are being crossed over is upside down or inverted, and we will be observing this in our investigation in class. The density of the cornea, aqueous humor, lens, and vitreous humor are all similar to each other and close to that of water. All of these structures refract light that passes through the eye to a greater or lesser degree. The refractive power of air, however, through which light travels to reach the eye, is quite different from and much lower than the refractive power of different parts of the eye. Therefore, the greatest degree of refraction in the human eye occurs when light moves from the surrounding air into the cornea of the eye at this point here, since the change in refractive power of the media is greatest at this point. So the refractive power of the air is 1, the refractive power of the cornea, is 1.38, so we have the greatest change occurring here. The lens is an interesting refractive structure in the eye. It is able to refract light to a great or lesser degree by altering its shape. This is termed accommodation and is useful in allowing the eye to adjust for near or far vision. The lens consists mainly of living protein fibers called crystallins housed in a lens capsule. These proteins are folded in a particular way to make them transparent. The overall shape of the lens, so its degree of curvature, depends on the degree to which the light can be refracted. And as we've already seen, it is these muscles and suspensory ligaments that help to change the shape of the lens, and that's what we'll be looking at in our next video.